Here is something people forget about an AI coding assistant. It is not just a chatbot, it is a program that runs real commands on your computer. It edits your files, runs your terminal, hits the network. And in July 2026, that turned into a nightmare for the popular editor Cursor. 2 flaws, nicknamed DuneSlide, rated critical, a 9.8. A single booby-trapped web page could hand an attacker full control of a developer's machine. No click required. Now, those specific bugs were reported and patched, fixed in Cursor version 3. But the lesson underneath them does not go away. If you let an AI agent run commands, you need a cage around it. And the interesting part of this story is how someone made that cage almost free. In the next few minutes, why an agent is so dangerous, how the escape actually worked, and the trick that builds a fresh cage in under a millisecond. Start with why an agent is different from a chatbot. A chatbot writes text back to you. An agent acts. To be useful, you give it hands. It can open and edit your files. It can run commands in your terminal. It can fetch things over the network. That reach is exactly what makes it powerful, and exactly what makes it dangerous, because an agent decides what to do next by reading text. Your instructions, sure, but also the contents of a file, the output of a tool, a page it fetched from the web. And here is the catch that sits under this whole story. It does what the text tells it to do. Even the text it did not write. Even the text an attacker slipped in. This is called prompt injection, a term coined by the security researcher Simon Willison, named after SQL injection. The root problem is simple and, so far, unsolved. A language model cannot reliably tell a trusted instruction from a malicious one, based on where it came from. To the model, it is all just text in the same window. Willison also named the recipe for real damage. He calls it the lethal trifecta. 3 ingredients. 1. The agent has access to private data. 2. It is exposed to untrusted content, like a web page or a document. And 3. It has a way to send data back out. Put all 3 together, and an attacker can hide an instruction in that untrusted content and walk your secrets right out the door. And the uncomfortable part? Each of those 3 abilities is genuinely useful. That is why the answer is to contain the agent, not to lobotomize it. Now watch how that played out in the real Cursor bug, DuneSlide, disclosed by the security firm Cato Networks. Step 1. The developer asks the agent something totally innocent, but the answer pulls in content from an untrusted source, a web search result, or a connected tool. Hidden inside that content is a payload. 0 clicks. Step 2. Now steered by the attacker, the agent breaks out of its sandbox. Cursor did run agent commands in a sandbox, but there turned out to be 2 independent flaws in it. In the first, the agent could tamper with a setting, the working directory, so the sandbox added a path it should never have allowed. In the second, when the tool tried to resolve a symbolic link and that check failed, it quietly fell back to the original path and wrote anyway. Either one, on its own, let it write where it should never have reached. Those are the 2 official records, CVE-2026-50548 and 50549. Step 3. It used that to overwrite the sandbox's own guard program, and from there it ran anything it wanted. Full remote code execution on the developer's machine. No click, anywhere. Remember, this was found responsibly and patched in Cursor 3. But sit with the shape of it. Cursor had a sandbox. The agent walked straight out of it. So step back and see the real danger clearly. It is not that the model says something rude. It is what the agent is allowed to do. The chain is always the same. Some untrusted content comes in, it becomes an instruction. The instruction becomes a tool call, and that tool call becomes a real command on a real machine, and that command runs with your privileges, your files, your saved credentials, your access to your company's network. The model is not the weak point. The weak point is the blast radius when a hijacked agent gets to touch your actual computer. Which is why, if the agent is going to run untrusted, influenced code, it needs to run somewhere that is not your actual computer. It needs a cage. So what is a cage really? It is a sandbox, a box the agent runs inside. It can freely touch whatever is in the box, but it cannot reach out and wreck the real machine. Now, not all boxes are equally strong. Roughly, from strongest to lightest, you have full virtual machines, then micro virtual machines like Firecracker, then user space kernels like gvisor, then ordinary containers, then things like WebAssembly. The single most important difference is this. A normal container shares the host's kernel with everything else. A virtual machine does not. It gets its own. Firecracker, the micro VM technology built at Amazon on top of Linux's KVM, was designed for exactly this problem, running untrusted code from total strangers, thousands of them, safely on one shared machine. Which is almost exactly the situation you are in when you hand your terminal to an AI agent. But strong isolation has always had a price. Booting a whole virtual machine is slow. Even a lean micro VM like Firecracker takes, at best, around 125 milliseconds to start your code. If you want a brand new, clean sandbox for every task an agent runs, that adds up fast. So here is a clever move from an open source project called ZeroBoot. You boot one micro VM once, then you take a snapshot of it, frozen in memory, And for every new sandbox, instead of booting again, you fork that snapshot. You map its memory as copy on write and restore the processor state into a fresh, isolated virtual machine. By the project's own benchmark, that fork takes about 0.8 milliseconds, not 125, under 1. A fresh, hardware-isolated cage for every single task at basically no cost. That is the idea that turns sandboxing from a luxury into a default. The trick at the heart of that is worth understanding, because it shows up everywhere in computing. It is called copy on write. Imagine 10 sandboxes that all start from the same booted machine. Naively, you would copy all of its memory 10 times. Copy on write says, don't. Let all 10 share the exact same memory pages, read only. Nobody has their own copy. The moment one sandbox actually writes to a page, and only then, the system makes a private copy of just that one page, or just that one sandbox. So the shared, unchanged parts stay shared. You only pay for what actually diverges. That is how a fresh, isolated machine can cost a millisecond instead of a full boot. One honest note: zero boot itself is a working prototype. The fork, the benchmarks, the interface are real, but the authors are clear. It is not production hardened yet. It is a proof that the idea works, not a finished product. And before you think a sandbox solves everything, the honest fine print. A cage is not a force field. First, it protects your host. It does not, by itself, stop data from leaking. If the agent is allowed to reach the network at all, a hijacked agent can still send your secrets out through that allowed channel. The lethal trifecta lives inside the sandbox too. Containment is not the same as prevention. Second, remember DuneSlide. Cursor had a sandbox, and the agent still escaped it. Sandboxes are software, and software has bugs, so the real answer was never one magic wall. It is defense in depth. Isolate the agent and give it the least access it needs, and treat every piece of input as potentially hostile. Micro VM forking is a genuinely strong new tool for the first part of that. It is a strong direction. It is not a finished solution. So here's the idea to keep. The AI assistant that writes your code is not a magic oracle. It is a program that runs commands, influenced by text it did not write. Treat it like exactly that. 3 things to watch from here. Throwaway sandboxes, spun up per task and thrown away, made cheap by tricks like copy on write forking. Least privilege, giving the agent the narrowest access that still lets it work, instead of the keys to everything. And a mindset shift, assuming the input is hostile by default, the way we already assume for anything that touches the open internet. The tools you hand real power to deserve real containment. If you want to understand the systems underneath headlines like this one, that is what this channel does. We build the intuition piece by piece. Subscribe and start with our free AI course. It takes you from the basics all the way up.